to our channel. So in the previous session we have seen the deletion operation. So how to delete an element or a node from the linked list. So in that we have seen how to delete an element from the beginning position, ending position, and from the specific position, right? So in today's session we will see two more operations, that is, one is the counting the number of nodes in the existing linked list. Second one is how to reverse the linked list, right? So first we will start with the counting. So finding the number of nodes present in the linked list. Right. We need to find number of nodes. So we know that it consists of two fields. One is the element, another one is the address. Let us take three nodes. So this is the null because it's the last node. Let it be 1000. 10. Let it be 20. Let it be 30. So address of 10 is 1000. Address of 20 is 2000. Address of 30 is 3000. So he holds the address of next node, so 2000 will be here. Address of next node, that means 3000 will be here. Right. This is the normal thing. Right. Let us take it as head. This is a head. Now, so the problem is we need to find how many nodes are there in the linked list. So for that, so let us write the code. So first, store the head with the temporary variable. So temporary is equal to head, right? Because we need to move the temporary variable from the first element till the last element. Now we have to use the iterations, right? We have to repeat the iterations. So while temp not equal to null, temp not equal to null. So until it moves to null. So here it is a null, right? If there is no node, that we can consider it as a null. So until temp not equal to null, we have to travel. So what we have to do? We have to count the number of nodes. So let us take the count variable, count plus plus. Initially take a count with a 0. Int count is equal to 0. Count plus plus. So one count will be incremented. Now we have to move from first node to second node. So this is a temp, right? Now we have to move this to this one. Now temp is equal to, we have to move this one. So what is the address of this one? Temp of next. So temp of next. So hope you understood this one, right? So we need to move this temp from first node to second node. So how to move this temp? So we have to move this temp to the 2000 address, because these are not the contiguous memory locations, right? So if it is a contiguous memory locations which we are used in arrays, simply we can increment the temp value, right? So there is a no rule that all the nodes should occupy the contiguous memories, right? So an element can be stored in any memory location, but that memory location address will be linked to the present node. So that's why in the linked list we are establishing a link between one node with another node by using this self-referential node, right? So temp must be presented, I mean the temp should be moved to the second node, which is in the memory location 2000. So this 2000 will be available in the present node, right? So head of next. So this is the head of data, head of the next. See. So if you consider one node, this is called head of data. This is called head of next, which we have seen in the previous session, right? Now temp is equal to temp of next. So temporary variable will be assigned to temp of next, that means 2000. So now this temp will be moved to here itself, right? Now again, just close it. Just close it. So again it will check for the condition, temp not equal to null. No. So here initially count is equal to 1, and now temp not equal to null. Again, count is equal to 2. So count plus plus, that means the count is equal to 2. So this is the first iteration, this is the second iteration. Again, temp is equal to temp of next. So temp is equal to, right, temp of next. Temp of next means 3000. Now the temp is assigned here itself, right? Now again, temp not equal to null. Temp not equal to null. Yes, true, because in this node 30 is available. So count plus plus. So now count is equal to 3, right? Again, temp is equal to temp of next. So temp is equal to, so next means null. That means null. Now again, temp not equal to null. Condition fails. Automatically it will exit from the loop. Here we can write the printf statement. So printf count is equal to %d count. So automatically this 3 will be printed here, right? So this is the code for finding the number of nodes in the linked list, right? Hope you understood this one. So we should not change the head value, so we are taking one temporary variable, right? One temporary variable, and we are assigning the head to the temporary variable before starting the iterations. So in next we are completely iterating, we are using the iterations so that we are counting the number of nodes by moving the temp from current node to the next node. So how to link that one? By using this statement, temp is equal to temp of next, right? So this is a small operation, that is finding the number of nodes in a linked list, right? Now we will see how to reverse the linked list. That means here 10, 20, 30. So 10 is linked with the address of 20, 20 is linked with the address of 3000. Now if you want to reverse a linked list, 30 will be the head. In the 30 it should have the address of 20, and in the 20 it should have the address of 10. So reversing, the first element will be 30, second element will be 20, and the third element will be 10. Now let us see the code and we will trace so that your doubts will be clarified, right? Right, now let us see the reversing of a linked list. Now let us take 3 nodes. So some 10, 20, 30. So the address is 1000, 2000 and 3000. So here it will be 2000. Here it will be 3000, here it will be null, right? So this is the head and this one is the tail. Now reversing a linked list. Now let us write the code and then we will trace it. So initially this one, so final output should be 30 will be the first element, that means head will be assigned to 30, and here head of next should be 2000, and next element will be 20, and head of 20 will be, next of 20 will be 1000, right? And here in the 10 the next element, the address will be assigned to now, because 10 will be the end element. So further we will take 2 more nodes, that is we'll use 3 more variables, the structure pointer variables, like previous, current and next. Right. Now let us write the code and then we will trace so that your doubts will be clarified. Now, so let us take the variables struct node. So we have declared a structure with a node, right? Struct node star current next previous is equal to null. So 3 nodes we have declared. Now okay, then just current is equal to head. So assign current is equal to head, because we need to move one element to the another, so that head should we can't move the head, so that just assign the head to the current. Right. Now, iterations. Follow the iterations because we have to move from first element to the last element by establishing the connections. Right. While current not equal to null, so unless the current not equal to null, these iterations will be performed. Right. The next is equal to current of next. Current of next is equal to previous element. Previous element is equal to current element. Current element is equal to next element. After completion of this one, just assign the previous node with the head. Right. So this is the simple logic for reversing a linked list. Right. Now let us see that. So this is the existing linked list. Now let us see first one, current is equal to head. So it points here itself. 10, 20, 30, here null, here 3000, here 2000. See. Right. Now current is equal to head. So here itself it is a head and also this is the current. Right. And also previous is equal to null. So star previous is equal to null. Right. So in the first, this is the initialization. First iteration. Iteration 1. After in the iteration 1, current not equal to null. So here if we are assigning the current to head, so current not equal to null. It's a true. Right. Okay. So current not equal to null, but here current is assigned with the 10 element. So this is a true, loop true. So it enters the loop. Now the next is equal to current of next. See here current of next is 2000. Current of next is 2000. So 2000 will be assigned to next. That means current will be here. Sorry. Next will be here. Right? Next, current of next is equal to previous. Current of next means this one. So this is the current, this is the next, this is the head, and previous is equal to null. Now current of next is equal to previous. So current of next, so this one is equal to previous means null. So 1000 will be removed and it is replaced with null. Hope you understood this one. Now previous is equal to, sorry, here I will write here. Okay, current of next is equal to null. Right. Now previous is equal to current. Now previous is equal to current. What is the current one? 10 is the current. Right. Now 10. So previous is equal to current. So this is previous. Right. Next, current is equal to next. Current is equal to next. Current is equal to next means 20 element. So current. Right. So after the first iteration, see, after the first iteration, the previous value is assigned to 10. The 10th element address field is assigned with null, and the second element is assigned with null, next, and current. Right. Now we'll go with the second iteration. So first we have to check the condition, and then we have to enter into the loop if the condition is true. Now, so this is about the first iteration. This is about the first iteration. Next, iteration 2. Iteration 2. Current not equal to null. So current is equal to 20. Is equal to 20, not equal to null. So true, condition is true. So now next is equal to current of next. So next is equal to current of next. Current of next means 3000. Now next is equal to current of next. So now the next will be assigned to this one. Next will be assigned to this one. Now let us see. Current of next is equal to previous. Current of next is equal to previous. So what is the previous? 10, right? Current of next. Current of next. So what is the current of next? So 3000 should be replaced with previous. So what is the previous? 1000, right? 1000. What's the previous? It's a 10 with the address 1000. So current of next is equal to previous. So as this is the address field, so this one is the address field, the address of field of previous, the address of previous should be assigned to current of next. So 1000 is assigned to here. So here 1000. Now previous is equal to current. Previous is equal to current. What is the current here? Current is 2000. Right? Current is 2000. Or 20. Okay. Simply we can write the element. Previous is equal to 20. And current is equal to next. Current is equal to next. Sorry, previous is equal to 20. So just move the previous here. Sorry. Now previous is here. Current is equal to next. So current is moved to next one. Current is equal to next. So current is equal to next means current is equal to, what is the next one? That is 30. Right. So this is the second iteration. Second iteration. Right. Now 10 with the address field null. Next 20 with the address field of 1000. That means 10 address field. Third one is 30 with the address field null. Now we have to change that one. In the third iteration, let us move with the third iteration. So unless you trace the logic, you can't understand, right? So that's why I am tracing the logic. Now iteration 3, again current not equal to null. Current 30. So 30 not equal to null. True. Then move with one. Next is equal to current of next. So current of next means null. Current of next means null. Next. Current of next is equal to previous. So current of next, this field, current of next is equal to previous. Previous means 2000. Right? Current of next is equal to previous. That means 2000 because previous is assigned to 2000. Now previous is equal to current. Previous is equal to current. Right? So this will be assigned here itself. Previous is equal to current. 30. Next, current is equal to next. Current is equal to next. Current is equal to next. Right? Next is equal to null. So here we can replace this next. Null. Current is equal to null because so here we have given the next is equal to null, and here current is equal to next means current is equal to null. Right? So now again, so this is the end of the iteration, third iteration. Now again it will move with the condition. So current not equal to null. This is false. Then the control will come out from the loop and head is equal to previous. So out of loop there is one statement. Head is equal to previous. What is the previous? 30. So here head will be removed here and it will be assigned here itself. Right? So 30 which is having the address field of 2000 which is of the next one, and 20 which is having the address field of 1000 of next one, which is 10 with the address field null, right? So after the completion of iterations we got the reverse. So first element 10, second element 20, third element 30. After the iterations, the first element head is 30, 20 and a 10, right? So we can just, no use of tail here, okay? There is no use of tail, right? So this is a simple logic for reversing the linked list. So just trace out it one. So if you trace step by step, automatically the clear cut understanding will be there, right? Yes. So if you are having any doubts regarding this reverse process and the finding the number of nodes, feel free to post your doubts in the comment section, so that definitely I will try to clarify all your doubts. And if you really understood my sessions, like my sessions, share my sessions with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.